Okay, if we want to do a numerical solution, we will include iteration process where we need to have a time step, and this step is limited to the final step. Maybe we want to make 100 steps in order to produce the curve that we want. So in this case, we want to create x curve based on this function, the gradient of the x curve. We don't know the x curve, but we know the gradient. So let's just start with the example. So let's say we know the first point. The first point is right here. So let's say it's at t value of 0 and x value is equal to 2. So we can write down that. So let's say we know that let's put it as t0 and x0, and we know that t0 is equal to 0, x0 is equal to 2. Okay, so from this point, what we can do is, after we know that this is the one point on the x curve, the curve of the x function, so we can find the gradient because we know the gradient equation right here. So therefore, we can calculate it. So how to calculate it is by putting these two value into this function, and we will get the value. So for example, we get a positive value, so we will have a positive gradient. So we can draw the gradient from that particular point. So we can draw that gradient. For example, it will be like this. So just draw like that. So in this case, we have known the first the gradient at that particular point. So now we want to find the second point of the curve. So what we will do is we need to decide the time step. So what is time step? Time step is this is the time, for example. So we want to decide what is the step. So the step we are the one who decide what is the step. So let's say I want to decide the step equal to 2. So the symbol that I will use is h. So h, this is the time step, is equal to 2. So when h is equal to 2, the next point should be 2. So this is h, right? So we can find the second point. Alright, so this second point, we can denote it as t1 x1. Alright. So how to know what is t1? So t1 is equal to t0 plus h. Simple, right? And how to know what is x1? So x1 is equal to x0 plus hf, this function, this gradient function, t0 x0. Alright. So why I use this this component? Because this is the gradient time the time step. So when we do that, we will get the increment of x. So what is this component mean is actually is this height. So this length is h f t0 x0. Alright. So hopefully you understand that. And when we add this component with this x0, we will get the x1. Okay, so that's how we get the second point. Okay, now we will not stop there. We need to continue with the similar method to get the third point. So what we will do is, right now we know the value of t1 and x1, so we can get the gradient at the second point. So when we put this value inside this gradient equation, so we can get the gradient at the second point. So when we calculate it, we can get the gradient, and then we can draw it again at the second point. So let's say the gradient increase. So like that, for example. Okay, now we have the second gradient, and then we want to know what is the second point. Where is the second point is, we need to use again the same time step. So we will h. So the second value of the third value of t is 4. Okay, so we know for this point, we know I denote it as t2 x2. Okay, so what is the value of t2? Again, I've told you. So for now, for this one, t2 is equal to t1 plus h. Okay, this t1 is equal to 2 right here, and when plus with 2, it will be 4 right here. Okay, how about x2? So we will use the same formula but different component. So right now x2 is equal to x1. Instead of x0, we use x1 plus h, same value, function, and in this function, in this gradient function, we use t1 and x1 to find the gradient at this point. Okay, so that's how we find the third point, which is t2 x2, this one. So we can continue again this process. I just show you another one. So we know these two value, and we can put again in this function to get the gradient, and after we put there, we can get the gradient at the third point. So let's say the gradient increase again, so I can redraw again like that, straight line, and then same time step, h. We'll make the straight horizontal line again. So that is the fourth point. So I denote it as t3 x3, and again the function, the equation will be t3 is equal to t2 plus h, x3 is equal to x2 plus hf, t2 x2. Hopefully you understand the equation that we use. So this process can be continue until a certain value of step. So for example, we want to make it 100 step, 1000 step. It's up to you. So we can continue until n step. 1 2 3 1 2 3. So t or n plus 1 step. So we can get the general equation Tn plus h. So x m plus 1 is equal to x n plus h f t n plus x n. Okay, now we know the general function. So this is the Euler method, or Euler's Euler's method. Okay, hopefully you understand that. So there you go. And now I want you to understand what is the effect of the h, which is the time step. Okay, let's say the answer for this equation, the answer for this problem is x is equal to x square plus, t square plus 2. Okay, that's why when t is equal to 0, x value is 2. Okay, so this is the actual solution. What I mean with actual solution is, so let's say the function of dx dt is 2t. So this is the function of dx dt. Okay. So when we know the answer, so from this equation, when we integrate it, we can find the actual answer. Okay, but instead of using the integration, normal integration, we can use from this equation, we can use the numerical method to find x curve, the curve of this equation, by using the numerical solution. Okay, so what happened when we change the time step? So let's say h, we reduce the value of h. So let's say I draw the actual solution. So this is example. Let's say I draw the actual curve of x. Let's say it will be like this. Smooth enough. Okay, it will be like that. Okay. So of course we will have this error when we use a numerical solution. We will have some error, but the error can be big and the error can be small. So when we use smaller time step, let's say I reduce the time step, h is equal to 1 instead of before this h is equal to 2. So what will happen is, so previously we get the curve like this. Okay, but when we reduce the time step, what will happen? I will choose other color. So this is the first point. When we calculate, we will get the second point right here, and we'll calculate again. Because we reduce the time step, so we will have even more calculation. When we calculate again, there's the next point, the next point. And finally the next one. Okay. This is example. So, what is the difference is, when we reduce the time step, the answer is converging to the actual answer. So actual answer is the correct answer. But this is the problem when we use numerical method, where we have error. But sometimes the error is acceptable. So in order to find the acceptable error, we need to make sure that the time step should be as small as possible. Okay. So what happened when I reduce h to become very small, 0.001 for example? The curve will be even smaller, even closer to the actual solution. So it will be like this. Okay, so this is example if h is equal to 0.001. So this one is h is equal to 1. Okay, so we want to make sure that the time step is as small as possible. But the problem is, when we make the time step become very small, we will need to do so many calculation. For example, when we use h time step equal to 2, in this case we only need to do 1, 2, 3, and 4 calculation only. But when we use time step equal to 1, we will need to calculate how many times? 1, 2, 3, 4, 5, 6, 7. Double the time, double the process. So we need to do more work if we use smaller time step. Understand? Okay, what happens if I use this time step? I will need to make calculation, so many calculation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, even 1,000, even 10,000 calculation to get this smooth curve. Okay, understand? So hopefully you understand that. So we need to consider two parameter, two aspect when we want to choose the value of time step. So the first one is accuracy, and the second one is workload or time consumption. Usually when we discuss or when we talk about numerical method, we will use computer to do the calculation, not by doing the calculation by yourself. But when we use, even though we use computer, when we choose very small time step, the calculation or the simulation, the calculation process will be long. But when we use big time step, the calculation process or the simulation process will be short. So we need to consider these two, and we need to find the value of time step is not too big and at the same time not too small. So we need to find the balance. So I think that is for the some input about the numerical solution. Hopefully you understand that. So now we can go to the next to the example, so that you can apply this and have more understanding about this topic.